Okay, so before we get into the next section and the problems that we've got to work out, we've got to look at some properties of logarithms first. So one thing that you've got to know is that if you've got log base b of m times n, we can expand this logarithm. And what we're going to do is we're actually going to create two different logarithms out of this. So remember that the operation that's occurring between m and n right there is that of multiplication. So whenever we multiply x's, or whenever we multiply things that are in that x spot, we can expand it out into two logarithms that are being added together. So this can become log base b of m plus log base b of n. Now, this can also go the other way as well. Instead of expanding it, you can condense it. So you can go from log base b of m plus log base b of n down to log base b of mn. Now, if you've got division, then we're just going to use subtraction instead. So this can be expanded to log base b of m minus log base b of n. And again, you can go this direction and then condense it. So they can go either way. Then if we have log base b of m to the n, this is a little bit different, but it's going to be the same thing here. We can take n and we can stick it out in front of the log. So it becomes n log base b of m. And we can also take anything that's out front of that log, and then we can make it into an exponent on that x value. So it can work both ways as well. So here in problem number 1a, we've been given log base 4 of 32 minus log base 4 of 2. And what we want to do is we want to condense them if we can, and then if we can, we want to actually see if we can solve it. So since you've got two logs that are being subtracted, what we're going to do to the x's is divide them. So this becomes log base 4 of 32 divided by 2. So 32 divided by 2 is 16. So we get log base 4 of 16. Now what we can do to that is we can take it and put it into exponential form. And remember that this is equal to y. So we get 4 to the y equals 16. Or we can say 4 to the y equals 4 squared to make sure that they match bases. Now that we've got matching bases, we can drop the bases and set the exponents equal to each other. So then we know that y is equal to 2. So the solution to log base 4 of 32 minus log base 4 of 2 is 2. Now over here in problem number 1b, we're given 6 log base 2 of x plus 5 log base 2 of y. Now again, we've got addition now between the logs, and we've got a 6 and a 5 hanging out in front of the logs. So I'm going to take care of the stuff that's hanging out in front first. So I'm going to rewrite this as log base 2 of x to the 6th, because this 6 is going to come over and be the exponent. This 5 is going to come over and be the exponent on the y. So then we've got plus log base 2 of y to the 5th. We've got addition between the logs, so we're going to take whatever is in that x spot. And when I refer to the x spot, what I'm talking about is log base b of x. So whatever comes in right behind this base. So we have x to the 6th and y to the 5th. So we're going to get log base 2 of x to the 6th, y to the 5th. Now it is very important that I point out that this can only be done if the bases are the same. If the bases are different, you won't be able to expand or condense your logarithms. Okay, so for problem number 2, we're being asked to expand logarithms. So in this first one, we've got log of 4x over y. So we've got a base of 10 on this one. Now what we're going to do with this, again, is we're going to see that we've got a y being divided into the 4 and the x. So that means that we've got to separate that, and we're going to subtract logs. So this is going to become log of 4x minus log of y. Now we've got the 4 times the x, so those can be separated by addition. So this becomes log 4 plus log x minus log y. And that's going to be the expansion. In problem number 2b, we're given log base 9 of x to the 4th over 729. So again, what we can do to expand this, we've got division here, so that means that we're going to have subtraction. So log base 9 of x to the 4th minus log base 9 of 729. So now what we would do is we would say, okay, is there anything we can do with this 9 and this 729? So if we go 9 to the y equals 729, what we would find out is 729 is equal to 9 cubed. So that means that y is equal to 3. So this entire part right here is the same thing as saying 3. Now we want to remember that and put that in the next time that we rewrite this line. We do have one thing that we've got to do on this one, and since we've got this 4 as an exponent, we can pull that out in front of the log. So this is going to become 4 log base 9 of x minus, and then since log base 9 of 729 is equal to 3, we're just going to write it as a minus 3. And that's how you expand them. Okay, so another new formula that we've got is the change of base formula. And the change of base is log base b of m equals log base c of m over log base c of b. We're going to use this whenever we've got a logarithm that we can't turn into exponential form and then solve for. So we've just got two numbers that we cannot get down to the same base on, so we're not able to solve it and figure out what the solution is. So that's when we're going to use the change of base formula. And again, it's going to be the common base is the c. So we're going to go m over b. Okay, so to show how this would work, we're actually going to use a problem that we could solve. We're going to use log base 81 of 27. So we're going to use the change of base formula on this. And to do this, we know that 81 and 27 have a common base of 3. So we're going to go ahead and use that as our new base. Now most of the time, you're probably just going to use a common log or a base 10 logarithm. But since we've got a common base of 3, we're going to go log base 3 of 27 over log base 3 of 81. So the way that this will work, I'm just going to go ahead and change these into exponential so you can see exactly how this ends up working here. So we've got 3 to the y equals 27 over 3 to the y equals 81. Well, we can change 27 down to a base of 3, and so that's going to give us 3 to the y equals 3 to the third. 81 can change to 3 to the fourth. So 3 to the y equals 3 to the fourth. Remember that once you've got the bases are the same, you can eliminate the bases and just set the exponents equal to each other. So now you've got y is equal to 3. So the answer to this is going to be 3 over y equals 4, so 4. So 3 over 4 is the solution to log base 81 over 27. Now in problem 3b, there's absolutely no way that we're going to be able to solve this without the use of a calculator. Let me show you why. If we were to take this and turn it into exponential form, we would have 5 to the y equals 36. There's absolutely no way we can take 36 and make it into a base of 5. We could do it with 25, we could do it with 125, we could do it with 625, but we're not going to be able to do it with 36. So we don't even want to try that. We just want to go straight to change of base form. This is where you're going to use your common log. So I'm going to do the log of m. So the log of m is 36 over the log of b, or the log of the base. So log of 5. So you get log 36 over log 5, and that is going to give you approximately 2.23. So again, this is one that you're going to have to run through the calculator to be able to get this. But it will work, and it will give you a solution to the problem.